Here we've got another theoretical yield type problem, and looking at the question it says what is the theoretical yield if 13.0 litres of CO2 gas are formed from 25.8 litres of O2 gas. Now in this situation you're obviously not going to just start with whatever number you see first. As with any other theoretical yield problem, what we've always got to start with is the reactant, and the reactant in this case is O2 and the product is CO2. Remember, the whole point of a theoretical yield problem is to see how much of a product we should be getting from a certain amount of reactant. Now we're starting out with 25.8 litres of O2 gas, but we're not going to end up with 13.0 litres of CO2. We're going to end up with something probably more than that. What we're going to have to do is figure out exactly what we're looking for here. Alright, so we're going to start out with 25.8 litres of O2 because that is the reactant and CO2 is the product. So we'll go over here, we'll start with 25.8 litres of O2. Now what we're looking for here is litres of CO2, and the reason for that is because the amount we're given here is in litres of CO2. Remember, the whole point of this is that at some point we might want to get a percent yield, and we can only get a percent yield if we find something that has the same units. So we don't want to find grams of CO2 or anything else, we want to find litres of CO2 so that when we do a percent yield we can figure out exactly what that percentage is by having the litres of CO2 cancel out. So we're going to start out with litres of A over here, and we're going to go to moles of A, then we're going to go to moles of B, and then we're going to go to litres of B, and what tells us that is what's in the problem. Alright, so we've got 25.8 litres of O2. Down here we'll have litres of O2 to cancel that one. We're going to go to moles of O2 first. The relationship between moles of O2 and litres of O2, 1 mole of O2, 22.414 litres of O2. Times, and then a line. Moles of O2 goes on the bottom to cancel out the moles of O2 up here. We've got moles of CO2 on top because that's what we're looking for. The relationship between moles of O2 and moles of CO2, 6 moles CO2, 9 moles O2, 6, 9. Down here we got times, we know moles CO2 goes on the bottom. And again, remember we're after litres of CO2 as mentioned over here. And that's going to give us 22.414 litres of CO2, 1 mole of CO2. And that's going to end up giving us 17.2 litres of CO2. So this ends up being the theoretical yield of CO2 in this instance. As you can see, it's more than the 13.0 litres of CO2 that we have in the problem, and if we wanted to we could then go ahead and figure out a percent yield, which would be 13.0 litres of CO2 divided by 17.2 litres of CO2 times 100%, and that's going to give us our percent yield. And as you can see, the litres of CO2 would cancel, and that gives us the idea of why we decided to go with litres of CO2 over here and find those.